Good day everyone! Today we will be demonstrating an interactive 3D 3x3 Rubik's Cube that we programmed using Python. In this short presentation, we will show three things: the original 3D object, the transformation applied, the final transformed versions of the cube, and the mathematical formula we applied. Let's start with the original object. What you see here is a 3x3 grid on each face of a Rubik's Cube. Each face has a unique color: yellow for the front, white for the back, orange for right, red for left, green for the top, and blue for the bottom. The cube is defined using 6 faces. Each face has 2 important properties. Number 1, the normal vector, which tells the direction the face is pointing. Number 2, the center point, which tells where the face is located in 3D spaces.
Let me now demonstrate how this cube behaves. So here is the cube in its original position. So dito, our front face is yellow, and the top face is green, and the side colors. And for our first transformation, it is rotation. I'll start rotating it using the arrow keys. Rotating right turns the cube around the y-axis. Rotating up tilts it along the x-axis. Page up spins it around the z-axis. And for the reflection, I'll demonstrate reflection. When I press the X key, the cube flips across the x-axis. This mirrors left and right. Pressing Y flips it vertically. Pressing Z flips it forward and backward. So these reflections are mathematical mirrors. They reverse the orientation of coordinates. So for our third transformation, we have scaling. I can make the cube bigger using the plus key or shrink it using minus. The cube is limited, so it can shrink too small or grow too large to avoid distortions.
Now, we will demonstrate the mathematical formula we used. We will start with the rotation. These 3 matrices each rotate the cube around one of the 3 axes: X, Y, and Z. Rx tilts it forward and background. Ry turns it left and right. Rz spins it like a clock. The angles in the matrices change when I press the arrow keys, which updates the cosine and sine values. That's why the cube rotates smoothly on the screen. Reflection. The reflection matrix is very simple. Each axis either keeps its sign +1 or flips it -1. When I press X, Y, or Z on the keyboard, the program multiplies the point by -1 on that axis, which mirrors the cube. Scaling. Scaling is straightforward. If the scale value is bigger than 1, the cube expands. If it's between 0 and 1, the cube shrinks. In my program, pressing plus or minus changed the scale value. To summarize, the transformation formula takes every point of the cube and applies reflection, rotation, scaling using matrix multiplication. That's what allows the cube to rotate, flip, and resize smoothly on screen. To summarize, we created a completely dynamic 3D Rubik's Cube using Python. We applied rotation, reflection, and scaling using mathematical transformation inside matrices. The result is an interactive object you can manipulate in real time. Thank you for listening, and we hope you enjoy it.